Hi, I'm Marina and I'll present the paper Investigation into the Impact of Simplification Aspects of Brazilian Energy Efficiency Simulation Interface S3E. From previous work, it can be understood that a simplified building energy simulation tool is either a tool with a novel code or an interface for an already established software that requires fewer inputs than the robust tools and provides simple results to be usable in the design or evaluation process. The different possibilities of simplifying the BS procedure can create significant divergences on results, so knowledge of the simplifications of each tool is essential to have dominion over their outputs. In Brazil, the Energy Efficiency Simulator in Buildings, S3E, is a free web interface for simplified building energy simulation that is under development. It uses Energy Plus as the simulation software and aims to make the energy simulation process simple and affordable to assist in developing more energy-efficient designs in Brazil. As results, users get the building label according to the Brazilian rating system RTQC and the total annual electric energy consumption. There is still little research about the influence of S3E simplification procedures, considering the use of the tool to simulate a real building. So, the aim of this paper is to preliminarily investigate the impact of simplification aspects on the results of both the energy efficiency classification and the annual energy consumption obtained by the interface S3E. The studied aspects are related to geometry, envelope description, and schedules. S3E offers 7 fixed options of regular geometries to represent the building's volume, with fixed thermal zones. It also offers a database of envelope components and 3 options for solar absorptance values. The chosen components are equally considered in all facades and the roof area. The full schedules are set according to the building's use typology. They are equally considered for all thermal zones by type of floor. Simulations of a real building were performed with S3E and Energy Plus to comparatively investigate simplification aspects of S3E. For each study case, the models of the 2 simulation tools were equal, changing only the analyzed parameter. After the simulations, the labels and the annual energy consumption obtained with both tools were compared. Energy Plus results were considered as the references. The Architecture School of the Federal University of Minas Gerais is located in Belo Horizonte, Brazil, and it was chosen because it presents volumetric complexity and different envelope compositions. Hence, the impacts of model simplifications could be better investigated. To enable the simulation of the complex volume, the building was divided into 7 blocks with geometries that followed the ones available in S3E. Some blocks were then chosen for the study. For the geometry and schedules studies, Block A was considered because it presents volume differences between floors, and for the envelope description study, Block F was chosen because it presents facade differences between floors and between orientations. To minimize S3E's limitations in what concerns the volume variation above a large window in the north facade, a sun protection device was added in the simplified model. For the envelope description study, the S3E model considered the weighted averages of values from the real building, while the Energy Plus followed the real envelope description. The default schedules adopted with S3E for the building's use school are constant during the year, while the ones considered in the Energy Plus model has patterns of use accordingly to time of year and the space usage. Only the schedules of occupancy, equipment, and lighting were varied on this comparative study. The S3E model had both area and volume approximately 6% inferior to the Energy Plus model. The strategy of representing the volume difference with the addition of a sun protection device would resemble the blocking of direct sunlight on the opening that was originally done by the building's volume. These adaptations to the geometry input simplifications were considered to be useful in the use of this simplified BS tool. It was noticed that the increase of energy consumption in the detailed model was also around 6%. Authors infer that this was due to the addition of air volume to be artificially conditioned. The use of uniform envelope values generated a lower energy consumption on the S3E model of approximately 3%. Although setting different envelope properties by facade and by floor could generate more precise results, the envelope description simplifications of S3E was considered to have little interference in the results. The strategy of using weighted average values was found to be useful in the use of the simplified Brazilian interface. The higher discrepancy between the results was found in the schedule study. The S3E model presented an annual energy consumption almost 150% higher than the Energy Plus model. S3E energy consumption was the highest on all end users. Since the installed loads were equal on both models, we assume it's the full schedules considered more operating hours than the real building schedules. S3E energy consumption for cooling was also higher than in Energy Plus, although the cooling loads and schedules were identical on both models. Authors infer that this difference is due to the increase in heat gains caused by lighting and equipment use. Nevertheless, all models obtained the same energy efficiency classification level according to the Brazilian rating system. Strategies used were useful to simulate a real complex building with the simplified building energy simulation tool. S3E was considered useful to be used on the design process to enable better informed decisions. Authors infer that the use of the simplified building energy simulation tools, such as S3E, could contribute to the broad use of labeling systems. Different scales and complexities of buildings with diverse functions should be included in further studies of the implications of S3E simplification aspects. Thank you.